An engine running on an air standard Otto cycle has a displacement volume 250 centimeter cube and a clearance volume 35.7 centimeter cube. The pressure and temperature at the beginning of the compression process are 100 kilopascal and 300 Kelvin respectively. Heat transfer during constant volume heat addition process is 800 kilojoules per kg. The specific heat at constant volume is 0.718 kilojoule per kg Kelvin and the ratio of specific heats at constant pressure and volume is 1.4. Assume the specific heats to remain constant during the cycle. The maximum pressure in the cycle is. Let us start the solution by constructing the PV diagram. In this PV diagram, process 1 to 2 exhibits adiabatic compression, process 2 to 3 is the constant volume heat addition, process 3 to 4 is the adiabatic expansion, and process 4 to 1 gives constant volume heat rejection. From the question, we know the displacement volume, which is also called as swept volume, and it is given as 250 centimeter cube. We know the clearance volume, it is 35.7 centimeter cube. Pressure before the compression is given as 100 kilopascals. Temperature before the compression is 300 Kelvin. Heat addition is given as 800 kilojoules per kg. Specific heat at constant volume Cv is equal to 0.718 kilojoule per kg Kelvin. The ratio of specific heats is given as gamma is equal to 1.4. Now for an Otto cycle, compression ratio Rc is given as the ratio of volume before compression to volume after compression. So for an Otto cycle, compression ratio can be found out as 1 plus Vs by Vc. Substituting Vs and Vc for this question, we get the compression ratio as 8. Now, from the basic thermodynamic relations, we have T2 by T1 is equal to V1 by V2 to the power gamma minus 1. We know that V1 by V2 is the compression ratio, so we can write T2 by T1 is equal to compression ratio to the power gamma minus 1. Now, from that, we can extract T2 is equal to T1 into Rc to the power gamma minus 1. Substituting T1 is equal to 300 and Rc to be 8 and gamma to be 1.4, we get T2 is equal to 689.22 Kelvin. We can also find out heat addition as Q in is equal to Cv into T3 minus T2. Substituting corresponding values, the only left out unknown will be T3 and it is obtained as 1803.426 Kelvin. Again, from the basic thermodynamic relations, we have P2 by P1 to the power gamma minus 1 by gamma is equal to Rc to the power gamma minus 1. Substituting the corresponding values, we have P2 is equal to 1837.92 kilopascals. From the already drawn PV diagram, it is to be noted that maximum pressure occurs in the cycle at point number 3. We know that PV is equal to MRT. In this particular air standard Otto cycle question, we can write P is directly proportional to temperature, and from that we have P3 by P2 is equal to T3 by T2. Rearranging the terms and substituting, we have P3 obtained as 4809 kilopascals. The accepted answer range for this question is 4780 to 4825.